Alright, in this video we're going to talk about Unit 1, Objective 4, which is trapezoidal sums. Trapezoidal sums, much like Riemann sums, are going to allow us to estimate an integral value, but instead of using rectangles like we did with Riemann sums, shockingly, we're going to be using trapezoids instead. AP generally will give you formulas like volume formulas, but one thing they won't give you, one thing they're going to expect you to know how to do is find the area of a trapezoid. So the area of a trapezoid, as you can see there, is 1/2 times the height times base 1 plus base 2. Now in geometry you probably learned it as base 1 plus base 2 divided by 2 times the height, or 1/2 times the sum of the bases times the height. But in calculus, I think it's better to do it 1/2 times height times base 1 times base 2, because a lot of times we're going to be able to factor stuff out and not have to worry about it too much. But all of those things are the same. As long as you know how to find the area of a trapezoid, you're going to be okay. The one warning I do want to give you guys about trapezoids in calculus, however, is what they look like. Generally in geometry, we would think of trapezoids as this. And we would say, all right, base 1 is up here, base 2 is down here, and then we would have to make a right triangle, figure out what the height of this thing is. Or maybe it looked like that, where base 1 was down here, base 2 was up here, and we have the height there, and we can figure out the area of the trapezoid that way. But the thing that we did most of the time in geometry is our bases were the top piece and the bottom piece. Now, if you go back to the definition of a trapezoid, the bases are parallel. So if you notice, the parallel sides on this trapezoid are the top and the bottom. Now, in calculus, our trapezoids are 100% of the time going to look like this. The only other thing they could look like would be that. They're never going to look like this. They're always going to look like this. And why I want to point that out is if you look for the parallel sides on this trapezoid, they're the left and the right side of the trapezoid. So in our mind, base is usually the bottom, and if we have more than one base, it's going to be the bottom and the top. But with the trapezoids in calculus, they're always going to have the bases on the left and the right, which means this bottom piece here is actually the height of our trapezoids. So that's the thing we need to keep in mind when we're doing our trapezoidal sums. I'm going to pull up the same polynomial we looked at when we did our Riemann sums. So we still have this function here. We're still trying to find the area under the curve from A to B. In this case is -2 to 1. Our answer is still going to be 8.814, but we're not going to get that exact answer, remember. We're just approximating. Now, n still stands for the number of trapezoids we're going to use. So we had before a left Riemann sum, we had the right Riemann sum, we had the midpoint Riemann sum. But now we're going to use trapezoids. So I'm putting in 3 trapezoids. Again, I'm using 3 because it splits up -2 to 1 nicely. And AP is not going to ask you to do something goofy. As you've seen with the trapezoid questions, most of the time you're going to get a table and you're not going to have a function anyway. But it's split up nicely, and you can see here I have one trapezoid here, I have one trapezoid here, and I have one trapezoid here. And if you notice, all of them have the parallel sides on the left and the right. So that means these bottom pieces here are going to be the heights of each of these trapezoids. Now, one thing I should have done in the last video, but I didn't, is kind of show you how the math works. So what we want to do is find the area of each trapezoid. So if we go back to our formula says 1/2 times the height times base 1 plus base 2. So if you look, the height of this first trapezoid, going from base to base, because remember the bases are the parallel sides, the bases in calculus are always going to be the left and the right. So the height of this first trapezoid goes from -2 to -1, so the height is 1. So we have 1/2 times 1. And then we need to figure out the bases. Well, to figure out the base, to figure out how tall this thing is here, well, that's just going to be how far it is from this to the function. So we just need to plug this value in to our function to get a value. So I've done that over here. If we plug -2 into our function, we get 3.4. The other base right here happens when we plug -1 into our function, and we get f of -1 is 2.03. So the area of this trapezoid is this first little equation here, 0.5, so the 1/2, times 1, because that's the height, times the quantity. You can see I have f of -2 plus f of -1. That's base 1 plus base 2. And that's going to give me 2.715. Now, if we do the same thing with these other two trapezoids, so f of -1 is this base, f of 0 is this base. So f of -1 plus f of 0, that's base 1 plus base 2. We have the 0.5. And you'll notice that our height is still 1. So that 2.245 is the area of this trapezoid. Doing the same thing here, our height's still 1, so we have 1/2 times 1. F of 0 gives me the base 1. F of 0 is 2.46. F of 1 gives me base 2, that's 5.7. So we add those two things up, multiply it by this piece over here, and we get 3.815. So 2.715 is the area of this trapezoid. 2.245 is the area of this trapezoid. And 3.85 or 815, sorry, is the area of this trapezoid. So if we add all of those things up, which I did down here, here's your first trapezoid, here's your second trapezoid, here's your third trapezoid, we get 8.775, which is what we get here. Now, that's a pretty good approximation. Trapezoidal sums are going to be usually the best estimation that we can get. And again, just like Riemann sums, if we add more trapezoids, we're going to get a better estimation than what we have. Now, again, I went to 6, so each of these heights would be something nice, in this case 0.5. But you could, if you wanted to, use 4 and get something goofy for your bases, but we're not usually going to have to do that. Like you've seen with the Riemann sums, it's generally going to be given to you in a table anyway, so you're not going to have to worry about plugging numbers in and figuring out the heights and all of that stuff. So yeah, very basic, just like just like Riemann sums. The only thing that you have to remember is your area for the trapezoid, and that our bases are the vertical pieces, the left and the right, the y values, not down here. That's going to give us our height. So that'll be it for this video.